let's try to solve this problem here. A person pulls horizontally on block B in the figure above. So there's a pull exerted by a person on block B, okay, causing both blocks to accelerate together as a unit to the right. So A and B, they are moving as a unit to the right due to the pull exerted by the person on block B. Okay, so block A doesn't receive a pull, but block A happens to accelerate together with B. So this is an interesting situation and we are going to study it further. While this system is moving, make a carefully labeled free body diagram of block A and block B. If there is friction between block B and the table. So they want us to draw a free body diagram for block A, they want us to draw a free body diagram for block B, and they want us to treat this horizontal table here as a rough surface because they say there is friction between block B and the table. Okay, so this is a situation which we rarely see in our syllabus actually, but it's a question that makes us think a lot about the situation on how one thing can move even though there's nothing visibly pushing it. Okay, so we'll be drawing the free body diagram for body B first. Because body B it's lying on the ground, which is a case which we see quite often, and we'll draw a free body diagram for for block A over here. So you do it for B, then A. Okay, so we'll use a dot to represent the object B over here, and again our axis will be in the horizontal and vertical direction. Just like usual, we're not rotating the axis because yeah, that's where it can move right, left, right. Okay, so now let's ask ourselves the 5 questions in order to determine all the forces acting on object B or block B over here. So first thing here, does this block B here has mass or not? Yes, this block B here is made of something, probably wood, so it should have mass. So if it has mass, then the earth is beneath it, you should have weight pointing downwards. So this weight will be exerted by the earth on this block B over here. So weight. Okay, next question, is this object B here, is it attached to any rope, strings or cables? Well, you see no ropes, you see no string, you see no cables attached to block B over here, right? So there's no tension. Third question, is there any force being explicitly mentioned or labeled in the diagram to show there's a external force? Yes, if you see here, there's a pull and the pull is being explicitly labeled in the diagram and it's being explicitly mentioned. It's pull horizontally on block B. This is a free body diagram for block B. So free body diagram of block B, draw all the forces that are being exerted on block B. So this person is pulling horizontally on block B. So this pull here should be included in the free body diagram. So you should expect there's a external force pointing to the right. Let's call this F. Okay, this F here is representing the pull. Okay, fourth question, is this object here, block B here, is it touching any surface or not? Yes, this object here is touching this horizontal table, and at the same time it is also touching object A over here. So you should expect two normal forces because there are two surfaces in contact for block B. So let's study the first surface in contact, which is the contact with the horizontal table. We know that the direction of normal should be perpendicular to the surface, and in choosing between up and down, let's think about the idea of push. The table is supporting the block B, okay? So if the table wants to push on block B, it has to push in this direction to support it, preventing it from falling. So the normal force should be pointing upwards. Okay, again, we have two surfaces in contact, so we have to study the second surface, which is the contact between block B and block A. So this force here will be exerted by block A on block B. So block A is now on top of block B. Block A is sitting on block B. So for block A to push on block B, you have to push downward, right? Because if pull will be upward, but normal force is pushing. So if block A is above block B, so block A you have to push. In order to push, you have to push downward. So therefore, we have a force exerted by block A on block B, and this force is pointing downward. Something like this. Okay, so now if we see in this situation here, we have two normal force, one normal force pointing upwards, one normal force pointing downwards. they are different, exerted by different things, so we need to label it. Again, to label normal forces or any forces, if it's relevant, we label it using the idea of by something on something. Okay, so for this normal force over here is exerted by the ground on the block B. So if it's by the ground on block B, if we substitute ground here, then on B, then our notation will be by ground on B. Again, it's always by first, then on. For our, if you follow my series, it's always by first, then on. So G, B. Okay, so this will be by ground on B. Okay, for this normal force over here, this normal force here is exerted by block A on block B. Okay, so it's exerted by A on B. So this one, the notation will be by A on B. So this one will be a normal force acting by A on B. Okay, so that's the fourth question being asked, and that answers whether there's any normal force or not. Let's move on to the fifth question. The fifth question is whether the surface are rough or not. Okay, so you are in contact with two surfaces, so let's study both of the surface right now. For this surface over here, well, we mentioned that there is friction between block B and the table, and since both blocks here are accelerating together to the right, they're accelerating together to the right, you should expect friction. So kinetic friction or static friction, if you look at this case, it's sliding across the table, right? Since it's sliding across the table, it will be kinetic friction. And this kinetic friction will be exerted by the table on block B. So what is the direction of this kinetic friction exerted by the horizontal table on block B? We remember for kinetic friction, it's opposite the direction of sliding. So the object B here, the block B here is sliding across the horizontal table to the right. So if we are going for opposite direction, that will be to the left. That means the kinetic friction exerted by the horizontal table on object B is to the left. So this one will be kinetic friction to the left. Okay, then the next one, we also have another surface over here. This surface between object A, block A and block B. So for this one, it's a bit tricky on how to determine the direction of friction. But first, let's try to determine whether it's static friction or kinetic friction. Between object A and object B, do you see any sliding between object A and object B? Well, they say the object, both blocks here, they are accelerating together as a unit. So it means by there's no B sliding across A, there's no A sliding across B. A and B move together as a unit. If A and B moves together as a unit, you should expect there's no sliding in between block A and block B. And since there's no sliding in between block A and block B, it should be a static friction. Okay, so since it's a static friction, we need to look at how to determine the direction of static friction. The direction of static friction, remember, for direction of static friction is opposite the direction of the sliding, opposite the direction of where the object tend to slide if the surface is smooth. Okay, that means if the surface in between A and B, if these two surfaces, if they are smooth, if they are frictionless, they are smooth, then once this object B, how would it tend to move? How would it tend to slide if these two surfaces here is smooth? Well, if the surface is smooth, then block B will be sliding while block A will remain at the same place, right? Because you just slide off like this. It's because of friction that A follows B. But because now if we imagine the situation, there's no friction, then B will be sliding under A. So the sliding motion is to the right. So you should expect the static friction to be opposite the direction where the object tend to slide. Okay, if the surface is smooth, the object B will tend to slide to the right. And opposite the direction should be our direction of static friction. So direction of static friction should be pointing to the left, and this is the static friction. Okay, so let's try to label it as well. This kinetic friction here is exerted by the ground on B. So let's label it's by the ground on B. Whereas for this static friction here is exerted by object A on object B. So this one will be A, B. Okay, so this will be the free body diagram for block B. Okay, I believe the one that many might have trouble with is to determine the direction of static friction due to block A over here. So block A here is actually exerting a static friction on block B. Okay, it's because if you think about it, if there's no static friction between block A and block B might just slide out like this, then block A will just fall like this. Okay, it's because block B exerts a frictional force on block A, that block A able to follow along. Okay, probably if we draw another free body diagram from block A, then you make the picture clearer. So let's make transition to block A over here. Let's try to draw a free body diagram from block A. So again, we use a dot to represent block A, and we put in our axis, X and Y. Okay, so let's ask ourselves the 5 question. Does this block A here, does it has mass? Yes, it has mass. It's made out of something, so there should be weight pointing downward, and this weight is exerted by the earth on block A. Okay, so next question, is this block A here, is it attached to any strings, ropes, or cable? No, you see no strings, no ropes, no cable, so no tension. Third question, is there any force being explicitly mentioned in the question or being mentioned in the diagram? Well, there is a force being explicitly mentioned, but it is not exerted on A, it is exerted on B. So it's not related to A. So therefore, there will be no external force that will be labeled for the free body diagram of block A. Fourth question, is this block A here touching any surface or any other objects or not? Yes, this block A here is touching block B. So since block A is touching block B, you should expect one normal force coming out because of this contact. So where should the normal force be pointing? We know that the normal force should be pointing perpendicular to the surface. So it's either up or down. Okay, so now this normal force is exerted by object B on object A. Object B exerts the normal force, object A experiences it. So think about the situation. So now object B is exerting the force on object A, so object B is down there supporting object A. So if object B is exerting the normal force on A, again normal force is a pushing force, so you should push upwards, right? Because if pull, then that will be not normal force anymore. Pull is downward, but that's not normal force. Normal force is push. So object B will exert an upward force, an upward normal force on A. So that means our normal force should be pointing upwards. Okay, then I think it's also good for us to label what force, this force is due to what. So it's by object B on object A. Okay, so we label by object B on object A. So we know that later if you want to do Newton's third law, we know that NBA and NAB forms an action-reaction pair. Okay, now you answered the fourth question. Let's move on to the fifth question. The fifth question asks whether there's any rough surface or not. Well, there is, because just now we mentioned the surface between A and B must be rough, or else there will be no friction. If there's no friction, the block B will just slide out like this. Okay, so this friction, there is a friction. So just now you also mentioned this friction will be a static friction because A and B move together as a unit. You see A doesn't slide across B, B doesn't slide across A. There's no sliding occurred in between A and B. So in this situation, even though block A is moving, block A is indeed moving to the right, but block A is not sliding across the surface between A and B. There's no sliding. When there's no sliding, then static friction. Again, static friction, the focus is sliding, not moving. You can be moving but having static friction as long as you don't slide. So in this case, A and B, they are not sliding across each other, so static friction. But now to determine the direction of static friction, we have to think of the situation, try to imagine the situation as a smooth surface. Then we see where the object tend to slide. Okay, so if we imagine this situation, this surface in between A and B is frictionless, is smooth, then if I pull object B, then object B will slide out like this, right? So object B is sliding out like this. You can think of it as A is sliding to the left of B. Okay, try to think of the situation. Now B sliding out like that, B sliding out like that is equivalent to us saying that A is sliding to the left. Because A is sliding to the left of B is equivalent to B sliding out, right? So if A is sliding out to the left of B, then that is a situation if the surface is smooth. Then opposite the direction will be the direction of static friction. Again, the direction of static friction is the opposite the direction where the object tends to slide if the surface is smooth. Now, if the surface is smooth, the object A tends to slide to the left. So opposite of left is right. So the direction of static friction is pointing to the right. So the direction of static friction should be pointing to the right. And we label this as Fs, and this is exerted by B on A. So now this is an interesting free body diagram because this object here, object A here, is able to move because of the static friction. We always think that friction causes things to slow down. Friction try to discourage things from moving. But in this case, we see that it's because of friction that object A, block A, is able to move. So friction, right, if you know how to use it, you can use it in various situations to your advantage. Like this situation here, even though you're not using an external force to pull object A, but because you know the idea of static friction, you can make object A move by using the idea of static friction. Okay, so if we do a calculation to determine the acceleration of block A, then the acceleration will be due to the net force, which is totally because of the static friction exerted by block B on block A. You can think of it as B is sliding, B is pulling A along. B is using the static friction to pull A along so that they accelerate together to the right. Okay, it might take some time for you to accept this free body diagram and how to explain it, but yeah, through a bit of analysis, you will probably understand it better. And of course, this static friction by B on A forms a reaction pair with static friction by A on B. Oh, I almost forgot something. Well, the W here, the weight for both free body diagram are using the same symbol W here. So I have to differentiate it using some kind of subscript. So in this case, since this is for block B, I will label this as WB, the weight for block B. Whereas for this one, it will be weight for block A. And I haven't labeled this as block A. Okay, so with that said, there will be a complete free body diagram for block B and block A.